myself Ankita, Faculty Department of IT, AKGEC. Today I am going to discuss MapReduce of Unit 2. Now in this video lecture, I will be discussing about fundamental of MapReduce, advantages of MapReduce and how a MapReduce job run actually works. And then finally, we will see how we can develop a MapReduce application. So in the last video lecture, we have discussed about Hadoop. So the functionality of Hadoop is that we are able to divide our task into multiple smaller tasks. That is, we are dividing our big data, or we are dividing the data across multiple commodity hardware, cluster of commodity hardware. So when we are dividing our data into cluster of the commodity hardware, it means that we have a possibility that we can analyze or process their data parallelly. So that is done by your MapReduce. So MapReduce is basically a software framework for writing applications to process the large amount of data across large clusters of commodity hardware in a reliable and a fault-tolerant manner. So basically, when we have our data across distributed across multiple nodes, what we can do is we can process them parallelly, and that parallel processing work is done by your MapReduce. Now, MapReduce basically have two tasks, that is map and reduce, that we will be discussing later in detail. And also we have two daemons of MapReduce, that is job tracker and task tracker. Now, it is to be noted that in Hadoop 1.0, these were the two daemons, that is job tracker and task tracker, which were managing the whole MapReduce job run, and it was a part of MapReduce only. After your Hadoop 2, these two tasks was done by your yarn, that is yet another resource negotiator, and the two components that were managing the tasks were node manager and the application manager. So these two, the work of job tracker was done by application manager, and the work of task tracker was done by your node manager. So to ease off your, you can say, to lighten the MapReduce work, the yarn component was introduced. Now, the term MapReduce refers to two tasks that the model refers to help chunk a large data processing task into many smaller tasks. So we are dividing, suppose we have the data across multiple nodes and we have to process the data. So what we can do, we can, chunk these tasks into multiple smaller tasks. The first task is your map task and the second one is your reduce task. Now, what does map task do? First, it takes the data and converts into a form of key value pairs. So we are converting the data into a set of key value pairs. Now, what does the reduce task do? Reduce task aggregate the values based on the same key. So that's the task of your reduce task. So we will be explaining this in detail in further slides. Now, two essential daemons are job tracker and task tracker, or you can say application manager or node manager. The work of these are similar to that of your job tracker and task tracker, but this appeared in Hadoop 2.0. In Hadoop 1, we were having job tracker and task tracker. So basically, job tracker, or you can say application manager, both are your master services. We have already discussed that we have master slave architecture in your Hadoop. So job tracker or application manager are master services, whereas task tracker or node managers are your slave services. Now, in the format of HDFS, where we have name node and data node, so name node will be having job tracker, whereas data node will be having the task tracker or application manager or node manager. Right? So let's understand the advantages of MapReduce. The first and the foremost advantage is your parallel processing. Since the data is distributed across various nodes, what we can do is we can parallelly process the data on these nodes, and that is done by your MapReduce. So here we are using the divide and conquer approach, which help us to process the data on different machines. So rather than we are processing the data on the single machine, what we are doing, we are dividing the data and running and processing the data parallelly on these nodes. So here the it is reducing at the processing time is reducing at a very tremendous amount. Next is your data locality. So in previous times, what we used to do, we suppose we have a data located at a place and we have a processing logic which is located at another place. So what we were doing, we were bringing this data to the processing unit to get it processed. But in your MapReduce, we are doing an opposite. We are bringing the processing logic to the data. Why? Because if we are bringing the data to the processing unit, what happens? Your network traffic increases. So when network traffic increases, it becomes difficult to manage. So it's better we are bringing lightweight processing logic to the data to increase the performance. So moving huge data to processing is costly and decreases the network performance, whereas also the processing task takes time. So instead of moving the data to the processing unit, we are moving the data to the processing unit, right? So earlier we were moving the logic to the data to the processing unit. Here we are moving logic to the processing unit. So that is your data locality concept. So the advantages of MapReduce are two. First is parallel processing, where we are analyzing the data in parallel across multiple commodity hardware, whereas in data locality, what does it mean? That we are moving the processing logic to the data nodes. Next, anatomy of MapReduce job run. Now here, this is a whole anatomy. The first, the file is in some input format. We are dividing that file into different input splits. Now, after dividing the format into different input splits, we are performing record reader operation on all of these splits individually. Then the output of record reader will give you an intermediate key value pair, which will be further processed by your map task. Now, this map task also generates of intermediary key value pairs, which is then partitioned, sorted, reduced and given in the output format. So we will be discussing this MapReduce job run using an example. Now first is job submission. So suppose I have a query to be made on a set of data in your Hadoop. So what I will do, I will have my query file called query.jar. So this will have my queries and what I want to get from the data. Next, I will be having a sample.txt. Now, this sample.txt is my input file which consists of all the data. Next, I will be having a result.output, which means that this will carry the output of my query. So, this I will be using a query like this, in which I will be passing my query. What information do I need? What is my input and what will be my output, right? Now, this is the query that I will be making as a user. Now, what I will do, I will make this query and this query is presented to job tracker or a resource manager. Now, these two are master service. In Hadoop 1.0, we had job tracker, whereas in Hadoop 2.0, we have resource manager, which is a part of Yarn. Now, you can see, now instead of bringing the data to the query or the processing element, we are bringing the query to the data. So, that is your concept of data locality. So, we will send this query to the data. So, we will not be bringing the data to our system. What I will do, I will send my query to that data. And for that, I will make this statement. I will give my input, I will give my output file, and then I will give my query. Now, next task is of job initialization. Now, this was job submission. I have submitted my job. Now, in job initialization, the job tracker or resource manager will receive the job and it will validate the job settings. So it will, tune out the various settings of the job. Next, now what happens, as you all know, that we are dividing the data across various nodes. So who will be having that information? This information, that which node is available on which data node, this information is in the hands of name node. So what now, the job is with the job tracker. Now job tracker will ask name node, yes, you please tell me where the data is actually located. So we have a sample.txt. Now this data file is distributed across various data nodes in various chunks. So we are dividing the sample.txt into various blocks. Now these blocks are distributed across various data nodes, and name node have the information that which part or which block is available at which data node. For example, my sample.txt is a whole file. It has already been divided into various blocks like first.txt, second.txt, third.txt and fourth.txt. Now these are the four, you can say, divisions that were already made on the input file and stored somewhere in your data nodes. Now the job tracker will have to know that where my data is located. Then only it will send the query to these data nodes. So it will ask the meta, that is name node, which will be having the information that which data is located at which node, right? So it will provide the information to the job tracker. Fine. Now, as you all know that in HDFS, we have a concept of replication, that one data block is kept in 3 nodes. It is replicated 3 times. So I have to access only one copy. So I will communicate with the task tracker. Now task tracker is available at the data nodes, right? I will communicate with all my data nodes, task tracker, to know, okay, are you active or not? If it is active, I will establish the connection with it. Okay. So that is your first work, that out of the 3 nodes which will be having the same copies of the data, I will be connecting with only one. After that, now we can say sample.txt is converted into input splits, that we are dividing the data and converting it into input split. Now in the Hadoop, the number of mappers for input files are equal to the number of input splits. Now for example, I have 4 input splits, so it will be located at 4 data nodes, and for each of these data nodes will be having 1 corresponding mappers. So here, if we are dividing my data into 4 input splits, I will be having 4 data nodes, right, and 4 mappers. So suppose this is my sample.txt, and what happens, I am converting it into 4 input splits. I am dividing the data into 4 input splits. Now the first input split is assigned to one mapper, second to another mapper, third to third mapper, and fourth into fourth mapper. So here we are having 4 mapper that has been done, and these mappers are present at data nodes. 4 input splits. Now 4 input splits means we will require 4 mappers. Now we have to understand that mapper only work on key value pairs. Okay. So now this is the data of one input split, and it is not a type of a key value. Now you have the map function or map task only works on key value pairs. So for our first task, so that is to convert this text into a key value pairs. So how can we convert a text into key value pair? So there are many methods, and this task is done by your record reader. So record reader, what does record reader do? It divides the data, or you can say it converts the data into sort of key value pair, which can be further processed by your map task, right? So here this each line in a text is termed as record. Now this is a record, this is a record. Now whole of this record will be converted as a key value pair. Now how we are converting a text into a key value pair depends on the input format. So if it is a text input format or key value text input format, a sequence or a sequence file as a text input format. So it depends upon the input type of my text. I will be applying record reader and convert it into a key value pair. So by default, the file is in the text input format and it can get converted into key value pair. How? It takes the byte offset and the data, right? This is your byte offset. So it is of 0th location and big data is big. Will form a key value pair, whereas the key will be the byte offset and the value will be the text. Next, the 18 is the byte offset of data is important and value is data is important. So we have converted a text into key value pairs and this is done by your record reader. So next step is that we will feed this key value pair to a mapper. Now what the mapper will do? It depends on the logic. Okay. So what we want our mapper to do? Suppose in this we are considering the task is that we have to find out the frequency of each of the unique words. So how many times big has appeared, how many times data has appeared. So I have to find out the frequency of unique words in this. This is my task. This is my work, this is my processing task. So what I will do, mapper will try to find out the frequency on each of these key value pairs. So here it has found out the frequency of big is 1, data is 1. In this data is 1, is 1. So this will be your intermediate data, right? This is the work of your map task. Okay? Map has converted this key value pair into an intermediary key value pair which have the key values of or frequencies of each of these data, right? Now, suppose I have another, suppose this D is capital D, right? Now, here also it will be capital D. Suppose this is my output of mapper. Now, there is another process called combiner which will combine. Ultimately, what we have to do? We have to find out the frequency. So, what I will do? The combiner, what it will do? It will check out if we have two keys, if we have two same keys, we will aggregate the values. So, here these two keys are same, data. So, what will combiner will do? It will give me the output big 1 like this. It will give me the response. So, it will aggregate the responses at one node. Okay, at one node. Next, we have partition. Now, partition will decide which reducer my task will go, right? So, it decides basically which reducer my next task will go. It decides because we have many reducers and we have to assign the reducer. So, basically, partitioner assign reducers. Next step is your shuffling and phase. Now, we have data distributed across various nodes, right? I have various nodes and data is distributed across various nodes, and at each of these nodes we are having input splits. Now, these input splits have your mapper and the response of each of these mappers. Now, what we have to do? We have to combine the results of all these mappers, right? So, we have mapper, this have output 1, output 2 and output 3. So, what happens? We have to combine these outputs and that is done by reducer. So, before the reducer, we have a phase of shuffling and sorting where all these outputs are shuffled together and same key values are sorted, shuffled so that they can appear together. And in reducer phase, what we do? we aggregate the values based on the keys. So if we have two keys, two values with the same key value, so we will aggregate them together in your reducer phase. So that is your shuffling and sorting. So basically, we have done this. That is, we are formatting the input into different splits. Then we are performing record reader to convert it into a key value pairs. Then applying the map part to find out the frequency of each of these words, and then partitioner, sorting, reducing, and output format. So this was your MapReduce job run. Now this is the output after getting the after running whole program. Now how we are going to develop a MapReduce application? So basically what is required as a programmer, what we do is write the code of mapper and reducer, how we want our map task to work and how the reducer task to work. So example was simple. We have split the data in the map phase. What we do, we assign the frequencies of each of these three words, and shuffle and sorting where is combining them together and sorting the same keys at one place, and in final reduction we are just adding up these two values. So we are trying to write a program for this MapReduce job run. Now what we do simple is, you are creating a class map which extends MapReduce base as well as implements mapper. Now these two are input types and these two are output. So this is the input that we will be getting and this is the output that we will be generating. Now this is your text that is line, as that is the input by record reader, and this is your, you can say, byte offset, right? Next is, I am creating a variable called 1 whose value is 1, right? Then I am creating a word of type text which will be having all this text, right? Now we have a map function. What our map function will do, it will assign frequency of 1 to each of the words that it is encountering. For that, first the line will be converted to a string, and then we will be having a string tokenizer which will be tokenizing the string, that is which will be extracting words from the string. Now the words is set, we will getting the word, and for each word we are extracting the word from the text, and for each word I am assigning a frequency of 1, right? 1, this value is here 1. So you can say, if my line is this, I will be assigning frequency of 1 to each of these. I will extracting a text from the string tokenizer, and then I will be assigning word, that is bus, and frequency, that is 1. That is your mapper code. In reducer code, what I am doing, I am trying to club this together into 2. Frequency of 1 is 2, right? Bus is 2. How I am going? Simple. This is my input, this is my output, and this is also my input. This is key value pair that is I am getting, and I will be collecting my output in an output collector. So if the value has if the key value is same, what I am doing, I am adding the values. If the key value is same, I am adding the values and writing out in a key. So that is your key reducer operation. So what is the driver code? First, I am configuring the MapReduce job run. This is my initialization. It will having the word count.class, and then word count.class is my text file. Then I will set my job name as word count, and I will then define my output key values, and then I will define my mapper, combiner, and reducer. Now you can see mapper I am defining at map.class, whereas in your combiner I am using the same logic of as reduce, because combiner have the same work which happens at one node, whereas reducer happens at the output of multiple nodes. So I am using the same reduce class for both of these two, and then I am setting up the input and output format, that is default text input format, and then I am giving you the path of the input and output files. So this is your driver code for MapReduce. Next is the whole program. You can see, have a look at it, and this program will tell you, it's just a combination, just same. Word count is my class name, this is my map logic, this is my reduce logic, and this is my driver logic. So these three are combined, will form you a MapReduce application.